Saha. Well, that's the way we say hello in Algeria. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of mathematics and to make your mathematics strong. So, children, this fascinating place that you get to see is Sidi Msid Bridge, Constantine, Algeria. It is 164-meter high, a suspension bridge, and is considered to be one of the highest bridges of the world. I'm sure you will find this place fascinating, as this is also a UNESCO place. Make sure to visit it. Here you will get to see that it is across River Rommel, which links Casbah to Sidi Msid Hill. Make sure to have macraoud, which is the famous Algerian sweet dish, which is really mouth-watering, that I can tell you, and also to tell all the people of Algeria that you get to meet Saha. In this note, children, I'm going to start off this lecture where first we'll be saying Saha logarithm or hello logarithm, and here we'll be looking up what actually logarithm is, what does it stand opposite to, what are the different constants, and how is it significant. Further, we'll be also looking up some formulae. Then we'll be looking up a sum which can relate all the formulae so that you can have a great foundation of what logarithm is, and then you'll be able to do the sums which are later. Now, children, here starting off with what actually logarithm is, I'm sure you people have dealt with exponential form, right? If you haven't dealt with, I have a lecture of exponential form or exponents, right, or indices. Do look that up. I'm sure your foundation of indices will become really strong. Now, children, to remind you a little, if say we talk about a number which is in exponential form, it is something like a raised to the power x, which is equal to b. Now here remember that when we talk about this a is actually the base. If you talk about x is the exponent, right, which, children, is also known as the index, or it is also known as the power. And if we talk about this b is actually the value of a raised to the power x, which becomes equal to b. Now here, children, we can say this way, that if we talk about multiplying a x number of times, right, then we will get to b, right? That is a when multiplied for x number of times, that's why we have a raised to the power x, that becomes equal to b. Now this is the exponential form, right? In this form we have a raised to the power x, which is equal to b. Now something which is opposite to this is the logarithmic form, right, Ashish? So if say we talk about the logarithmic form can be said to be something which is opposite to the exponential form, right? Now if we want to write the above, that is a raised to the power x is equal to b, in the logarithmic form, then we will write it with the same base. That is, the base here was a, so the base will remain to be the same, and in a way you can say that the top entities can exchange their positions, or in other words you will say that log b to the base a is going to become equal to x. So here we can say that if you talk about finding out the log, that is actually trying to find out the value of the exponential to the same base, which is actually equal to the index, right? So this is a way of saying what actually logarithm is. Now here I'm sure you're able to see that there are two constants, one is a and the other is b. For that, you've got to remember that a and b both have to be greater than 0, or in other words both have to be positive. Now another thing which is true about a and b is a and b both can be from the set of real numbers, that is, they can either be rational or they can be irrational, right? So this is all about logarithm, right? When we talk about the concepts, now I'll just quickly discuss all of this with you so that if there is any doubt, all of that gets clear. Now, when we talk about the logarithmic form, that is considered to be antagonistic, or it is considered to be opposite, right, to the exponential form. Now, if you talk about a raised to the power x, then that's equal to b. This is what the exponential form was. And here, children, a was the base, x was the exponent, which is also known as the index, which is also known as the power, and its value is equal to b. This actually means that if you talk about a to be multiplied x number of times, then that gives you b. Now, opposite to this, or contrary to this, if we talk about the logarithmic form, here we talk about log with the same base as the exponential form, but if you talk about the top entities, they have exchanged their positions, or in other words, you talk about log of b to the base a, which becomes equal to x. And that is the reason why we can say here that if we talk about log, then we talk about actually its value of the exponent that we are trying to target, right? And that is, we talk about log b, which was the value of the exponent. Base remains to be the same, and we equate it to whatever was the exponent or whatever was the index in the exponential form, right? Now, children, here there are two things which are very, very important. That is, if you talk about a and b, both of these have to be positive, and a and b can be from the set of real numbers, or in other words, they can be either rational or irrational. Now, children, here log of a positive number is only what you find out. So whenever you talk about this b, right, this is actually log of whatever number you are to find out, and that always has to be positive, and the base also has to be positive. This is what is meant by it, right? So here, children, further, as now we talk about the basic entities which are there about logarithm, further next comes now the formulae which are related with logarithm. So next now, children, we'll be talking about the different formulae that are there. As you know that if you talk about formulae, then it is actually the plural of formula. Formula is just for one, and formulae is for many. It is not written like formulas, right? So here, children, if you talk about the first formula, you should know when is it that log is possible. For that matter, if you talk about log of 0, you got to remember that whatever be the base, then it is undefined, right? So excuse me, never try to find out log of 0. To whatever base it is, it will always remain to be undefined, right? Now, children, next is, if say we talk about log of 1, right, that is always 0, right? So if say we talk about log of 1, which is to any base, right, that is going to come out to be 0. Now, how do we get to this? We will just quickly look it up by writing this, say, in the exponential form. Now, let's say we talk about log of 1 to the base 7, say, and we take it to be equal to 0. Like I said, it can be to any base. Obviously, the base can be 7. So here, children, if we try to write this in the exponential form, we will have the same base, and the top entities will exchange their positions, or in other words, we will have 7 raised to the power 0, which will become equal to 1. And this is by the rules of exponents that you already know, that if you talk about any number which is raised to the power 0, that becomes equal to 1. And this is the reason why this exists, or in other words, if you talk about log 1 to any base, it is always 0. Now, children, few rules which are applicable again and again and again. So if say you talk about log of a product of two numbers, that is a and b, then that becomes equal to log of a, to which log of b is added. Next now, children, if say we talk about log of a ratio of two numbers a upon b, right, then that becomes equal to log of a, from which log of b is subtracted. Next rule is, if say we talk about, say, some log of a number which is a raised to the power m, or in other words is in exponential form, then that will become equal to m, which is multiplied with the log of a, right? So, children, here first I will be discussing all of these rules, then after that I'll be telling you few more rules, and after that then I'll be telling you something which is really special. Okay, so here when we talk about log 0, right, remember that that is undefined. when we talk about log 1, if it is to any base, it is always 0. So here, so that you can remember, I will just quickly write here that if you write it to any base, remember, it is always going to be 0, right? Now here I give you an example that if you talk about log of 1 to say any base that is 7, again it's going to come equal to 0. Why so? Because if you write this logarithmic form in exponential form, it is going to become 7 raised to the power, the top entity is getting exchanged, so 0 becomes equal to 1. Now, as you know that any number raised to the power 0 is 1, so as such a raised to the power 0 will also become equal to 1, right? And that is the reason why this is going to be true, that is log 1 to any base is always going to be 0. Next, now we have the log of a product of two numbers will become equal to the sum of the log of both the numbers. Now if we have the log of a quotient of two numbers, then that will become the difference of the logs of both the numbers. Then if we have log of a number which is in exponential form, then it will be the index or the exponent times log of that number a, right? So these are the basic rules. Now children, after this we will quickly be looking up the log base change formula. So if we talk about the log base change formula here, then what happens is we will have here say some log of a which is to say some base b, right? Now here children, we can write it as log of a to any base divided by log of b to any base. Now when I mean any base, I'll give you an example. Let's say we talk about log of 7 to the base 6, right? So here children, we can write it to be log 7 to the base 11 divided by log of 6, right, to the base 11. So here we have here this log base change formula, right, where 6 no more remains to be the base, but the base becomes equal to 11, right? So if here you have log of a to the base b, then this base can be changed as writing this as log a to some base divided by log b to the same base. Now this can be done for any base value. For that matter, I have given you an example here. If you have log 7 to the base 6, then that can be written as log of 7 to any base say 11 divided by log 6 to that same base 11, right? Here in place of 11 we can even write 13, or for that matter we can write any number, right? Now children, here if say we talk about this rule, this was the log base change formula, right? So as this has a special name, so I will quickly write this here, log base change formula, right? Now here children, we will be talking about another rule which is pretty similar to this, right? And here we have it something like this, that is, if say we have some log of a to the base b, right, we can write that as 1 upon log of b to the base a, right? Or in other words, if say we talk about log of a number to another number as base, then that will be equal to log of 1 upon writing the reverse order. That means that number whose logarithm was being found out, in place of that you will write the base, and in place of the base you will write that number of whose logarithm you were finding out. Now here also I will quickly give you an example. Let's say now we talk about log of 17 to the base 11. Now this can be written as 1 upon log of 11 to the base 17, right? So here what have we done is we have changed the base and that number whose logarithm we were finding out, and what happened was it just became the inverse, right? So this was by swapping the number whose logarithm we were finding out with the base, and when you do so, here you will get it to be the inverse of the earlier, right? Now children, here I'm sure you people must be having a empty feeling when we talk about the base, because many a times I have written this to be just nothing. So here children, I'll just quickly give you an idea. about what the base is. Now, normally when we talk about the base for simple calculations, we call it to be common logarithm, right? So let's say we talk about log of 2. So if it's written like log of 2 normally, right, and when you're talking about common logarithm, then the base has to be 10, right? So what did I say just now? That if say you talk about log of a number when the base is 10, then this is known as common logarithm. Right? Now this common logarithm is also known as decadic logarithm, right? So this is also how we know it. That is, this is another name of this logarithm. That is, we call it to be decadic logarithm, right? So this is another name of it. Yeah, I know this is a little funny, Ashish, but this is what its name is. This is also known as the Briggscian logarithm, because this was the name of the mathematician who found it, Mr. Briggs, right? So that's why it is also known as the Briggscian logarithm, right? So these are different names by means of which the common logarithm is called, right? It is also known as the standard logarithm. That is another name that you have for it. So if you ask your friends, I'm sure they will have a hard time telling you the synonyms of what common logarithm is, right? So if you talk about decadic logarithm, or if you talk about Briggscian logarithm, or if you talk about standard logarithm, they're the same as the common logarithm. That is when the base is 10. Now here comes the more important entity. That is, if say we talk about higher classes, and then if say we talk about the base not being written, like suppose we talk about log 3 and here the base is not written, it automatically means that the base is e. Now what is e? E is known as the Euler's number, right? So what is e? E is known as Euler's number, or the Euler's constant, right? This was found out by the mathematician Euler. Now children, what is this equal to? This is equal to 1 plus 1 upon factorial 1 plus 1 upon factorial 2 plus 1 upon factorial 3, and all of this continues up to infinity. That means up to the end that you can't reach. Okay, so here when we talk about the factorial of a number, now what does that mean? If say we talk about say some factorial 7, then that will mean that you start off from 7, multiply it with one natural number less, and all of that process has to be continued to be one natural number less, and so on up to the first natural number, which is 1. So this gives you factorial of 7, and similarly you can find out the factorial of 19 as 19 into 18 into 17 and so on. That is multiplied up to 1. So now children, here if say we talk about Euler's number, we can calculate its value approximately. That is, here we have 1, then 1 upon factorial 1 will also be 1, so 1 plus 1 then becomes equal to 2, to which if you add 1 upon factorial 2, which will be 2 into 1, which will become 1 upon 2, that is 0.5, and further as you find that all the denominators are increasing, so the value of all of these fractions is decreasing, and that approximately comes to 0.2. So if you talk about Euler's constant, that approximately comes to 2.7, right? So this is a constant which is the general base, right? So you've got to remember this, that whenever you talk about any logarithm which has not been given its base, then this is the general base, which automatically means, right? So this is the general base, and above we had the common logarithm where we had 10 as the base, right? Okay children, so these concepts now I'll just quickly discuss with you. So we had already discussed about few rules, that is up to here, of logarithm. Now we'll be looking up the rest of the formulae. Now I told you about the log base change formula. That is, if say we talk about log of a to the base b, then that becomes equal to log of a to any base divided by log of b to the same base, Now here children, I give you an idea. That is, if say you talk about log of 7 to the base 6, then that will become equal to log of 7 to any base, that is 11. Now in the denominator also it has to be the same base, that is 11, log of 6, that was the number which was there in the base, right? So this is how we applying the log base change formula. Now next children, after this we have the swap formula. That is, if suppose we talk about log of a to the base b, then that will become equal to 1 upon log of b to the base a, right? And here we can look it up by this example. That is, if we talk about log of 17 to the base 11, then that will become equal to 1 upon log of 11 to the base 17. That is, here log of the number that was being found out has been swapped with the base. Now children, after this we now talk about another important entity, that is something about the base. When normally you talk about logarithms, it is to a base 10. Excuse me. Now when the base is 10, then the logarithms are known as common logarithm. They are also known as decadic logarithms. They are also known as Briggs'ian logarithms, or they are known as standard logarithms. Briggs'ian logarithm, because Mr. Briggs was the mathematician who was one who found out about this. Now children, here we now next talk about a logarithm which is known as general logarithm. That is, when a logarithm is to the base e, or when the base hasn't been written, then especially in higher classes you write it to be e, to be the base, where e is the Euler's constant. So when the base is e of the log of any number, then it is said to be general logarithm, and the base is said to be general base. Now here children, when we talk about the Euler's constant, it is 1 plus 1 upon factorial 1 plus 1 upon factorial 2 plus 1 upon factorial 3, and all of that continues up to infinity. That is, say, a very very farther point which normally you can't reach, right? Now children, the value of this approximately comes to 2.7. How so? As 1 is 1, 1 upon factorial 1 will remain to be 1, 1 upon factorial 2 will be 2 into 2, that is 1 upon 2, that is 0.5. So all of this adds up to 2.5, and further all of these rest of the numbers, as the denominator is increasing, their value is decreasing, they all add up to 0.2, and that is the reason Euler's constant approximately comes to 2.7. For that matter, when we talk about the factorial of a number, it means that it is the product of the number with one value, with one less a natural number than itself, further multiplied with a natural number which is just one less than its earlier number, further multiplied with another natural number which is just one less than its earlier value. All of this continues up to the first natural number, that is 1. Now children, having known all of these basic things about log, now next we come to a sum, which I'm sure is going to give you a better picture about how log works. Make sure you first try out the sum, and after that then you will have some time where I'll be discussing the sum with you. And further, after you understood the sum, make sure you pause the lecture and do the sum once, well, all by your own. If you've not been able to do it and you stumble, you are to look up somewhere, then make sure to do it once more, right? So that all this knowledge gets very well encapsulated with you, and all of the knowledge is very well assimilated. Okay children, so here now we look up this sum, and here we have to prove that 2 log 15 upon 18 minus log of 25 upon 162 plus log of 4 upon 9 is going to become equal to log 2, as I can see it. Now further, I will try and show this more to you people by making this brought a little towards the left hand side, which further I'm going to shrink a little, and then I'm sure you'll be able to see it properly. Okay, so you can see this now, that all of this is going to look like log 2, right? So we start off with the left hand side and we try and prove it equal to the right hand side. So going ahead with the left hand side, we find that we have 2 times of log of 15 upon 18. So here children, we are quickly reminded of a rule that if say we talk about say a whose log is being found out, right, which is raised to the power m, then that becomes equal to m times of log of a. And as here this is m times of log of a, thus this should become log of 15 upon 18 raised to the power 2. So this is what we're going to write here. That is, this is going to become equal to log of 15 upon 18 raised to the power 2, right? And from that is subtracted log of 25 upon 162, and to that is added log of 4 upon 9. Now further here what we can do is we can apply the other rules, right? And before we do so, here we can do one thing more. We can write all the numbers in terms of their prime factors. So here children, in the next step now, we can write this as log of 15 can be written as 3 into 5, right? And 18 can be written as 9 twos is 18, so it can be written as 2 into 3 into 3, as we write it all in terms of their prime factors, and all of this is raised to the power 2. And further then we have minus log of 25 can be written as log of 5 square, and if we talk about 162, that is 81 into 2, and thus it becomes 2 into 3 raised to the power 4, as 3 threes is 9, 9 threes is 27, 27 threes is 81, right? Further then children, we talk about the next number, which is pretty simple. That is log of 4, which will become equal to 2 square, and it is divided by 9, which is 3 square. Next now children, we will quickly be reminded of a rule, that is, if say we have log of the product of two numbers, then that becomes equal to log of the first number plus log of the second number, right? And similarly, if say we talk about log of a ratio of two numbers, then that becomes equal to log of the first number from which log of the second number is subtracted. Now here children, next what you're going to do is, here we're going to apply these rules. So next now you can write this as log of 3 raised to the power 2 into 5 raised to the power 2, which is divided by 2 raised to the power 2, and as this is 3 raised to the power 2, which is whole raised to the power 2, it will become 3 raised to the power 4. Here children, we have used two rules of indices. One, that if we have a into b, which is raised to the power m, then this is going to become equal to a raised to the power m, which will be multiplied with b raised to the power m. And at the other time, if say we have some a raised to the power m, which is whole raised to the power n, then that becomes equal to a raised to the power m into n, right? So we have used this rule as well here when we talked about 3 raised to the power 2 becoming 3 raised to the power 2 whole raised to the power 2, that is 3 raised to the power 4. Now next children, after this, as there is a subtraction sign, so we'll be applying the second rule, and thus we'll be writing divided by, and we'll write the number next now, that is 5 square upon 2 into 3 raised to the power 4, right? As when we had log of a upon b, just like this, right, then that became log of a minus log of b. Further children, added to it is log of 2 square divided by 3 square, as it is added. So obviously here we can put up a multiplication sign, and we can write the number, that is 2 raised to the power 2 divided by 3 raised to the power 2, and here we can put all of these numbers together. Now here further, first we will convert the division sign to multiplication sign as is normally done in BODMAS. So here we'll have 3 raised to the power 2 multiplied with 5 raised to the power 2 divided by 2 raised to the power 2, which is further multiplied with 3 raised to the power 4. And further here we can convert the division sign to multiplication sign, and then we'll write the reciprocal of the fraction which comes next, that is 2 into 3 raised to the power 4, and in the denominator we have 5 raised to the power 2, which is further going to be multiplied with 2 raised to the power 2 divided by 3 raised to the power 2, and here we close the bracket, that is the brace bracket. Now next children, there will be certain terms which will get cancelled from the numerator and from the denominator. So now we're going to do that. That is, here we get to see that 3 raised to the power 2 will get cancelled with 3 raised to the power 2. 2 raised to the power 2 will get cancelled with 2 raised to the power 2. We have 3 raised to the power 4, which will get cancelled with 3 raised to the power 4. We have 5 raised to the power 2, which will get cancelled with 5 raised to the power 2, and thus we are just left out with 2. and thus in the next step now we can write this as log of 2, and if you check out with what we require to bring, we would require to bring log 2, and therefore we can say that this stands to be equal to the right hand side, and thus we can say that the sum stands proved. Right? So Ashish, understood? Surely? Okay. Now children, I'll just quickly discuss the sum all over. In the question, you've been given that you have to prove 2 times of log of 15 upon 18 minus log of 25 upon 162 plus log of 4 upon 9 is equal to log of 2. Now here children, we will be applying all the rules which are there in log, right? And then we will get to answers, and whichever rules are applicable, make sure you write them with black ink, because normally you'll be using blue ink to do your classwork. So here children, the first thing that we can do is, as we know that if we have some log of a raised to the power m, then that becomes equal to m times of log of a. As such here, this 2 should be the power of 15 upon 18 that has been written here. Next, what we do is we now talk about writing all of these numbers in terms of their prime factors. So 15 becomes 3 into 5, 18 becomes 9 into 2, that is 2 into 3 into 3. Then further here we have 25, which can be written as 5 square, 162, which can be written as 2 into 81, right? That is 2 into 3 raised to the power 4, because 3 into 3 is 9, and again 3 into 3 is 9, 9 nines is 81, right? And further 4 can be written as 2 square, 9 can be written as 3 square, right? So we have written all these numbers. Next, now we find that we have log of a into b, which can be written as log a plus log b. So as we have this plus sign, right, of log of a plus log of b, then that can be written as log of a into b. So then we can multiply these numbers, and whenever there is a minus sign like log a minus log b, obviously then we can talk about log of a divided by log b. So we'll use that here then. So we have log first written, then we have the first number written. When there is a minus sign, obviously the second number with the log is going to be in division with the first number. Now the next number, as it is coming after plus log of that number, so here now next we'll have a multiplication sign with 2 square divided by 3 square. Now further children, next what we do is we will now change the division sign to multiplication sign, and we'll write the fraction which is after it, right, to be the reciprocal of what it was. So that will become 2 into 3 raised to the power 4 divided by 5 square. Now here next what will happen is common factors will get cancelled. 5 square will get cancelled with 5 square, 3 square will get cancelled with 3 square, 2 square will get cancelled with 2 square, and 3 raised to the power 4 will get cancelled with 3 raised to the power 4. As such, we'll just be left out with 2, and that thus becomes log 2. And children, in the right hand side you are required to bring log 2, and thus this is equal to the same as the right hand side, and thus this stands to be proved. So is everybody clear about this? Now you got a good roundabout idea, right? Or you have a full view idea about what logarithm is, how the different rules are applied. I'm sure when you study more, you'll get to know more. For that matter, right, if you feel that there are certain topics in which you require more help, there is the app, right, the mathematics helpline, where you can go and get some help, right? Make sure that you find its link in the about section of this video, and this will also be there in as the first message, right, or the first comment, right, where you can get to see that. And then when you click on it, you will get to see many things that you can look up, and you can make your mathematics more strong. So I'm sure, as I'm on a mission to help out more and more children to become strong in mathematics, you are also on a mission to make your mathematics strong. So children, go ahead, don't be scared about mathematics, fight it out, and I'm sure you will win this battle. So bye children, have a nice time and do more maths. Bye.